This week we're going to continue with series. So we're going to look at an example of root test. We have the sum from n equals 1 to infinity of n to the n over 3 to the 1 plus 2n. And because of this x1 right here, we know that we're going to want to use root test. So we have root test over here, just so we can look at it. And the first thing we do is take the nth root of the absolute value of this an. Remember that this part is our an. So taking the nth root is the same as taking it to the 1 over n, which I think is easier to understand. So our an is n to the n over 3 to the 1 plus 2n, all taken to the 1 over n. And this is just going to give us n over 3 to the 1 over n. Because remember, we can sort of separate these two because of properties of exponents. And then we have 2n to the 1 over n, so this is just going to be plus 2. So what we do now is we take a limit. So we have the limit as n goes to infinity of n over 3 to the 1 over n plus 2. So n, as it goes to infinity, it's just going to be an infinity over 1 over n. 1 over infinity goes to 0. So that's just going to be 3 to the 0, which is 1. And then we have this, because we can rewrite this as 3 to the 1 over n times 3 squared. So this just goes to 3 to the 0, which goes to 1. And then we just have this 3 squared. So we have infinity over 3 squared, which we know is still going to be infinity. And this is our row. So we look over here and we see that this row of infinity is greater than 1, which means that the whole thing will diverge. And that's it.